Well, welcome everybody to session 2B, evaluating emissions and anthropogenic activities. We have 4 great talks on tap, 10-minute talks. We'll save the Q&A at the end. We're trying to be timely with our talks, so we have our helper here putting up signs to monitor the time. Try to stay that time if you can. And our first talk today is from Tracey Holloway. Obviously, everybody knows Tracey Holloway, HAQAST lead. And here's a mic. Slides.
Thank you, Aaron. Thanks everyone for being here. It's really a pleasure to not just welcome you to HAQAST, but to share some of the work that my team and colleagues have been doing here at the University of Wisconsin-Madison. Okay, so first I'll note that at the University of Wisconsin, I work with a great team of staff and graduate students and undergraduates and collaborators. And so some of the work that I'm going to be talking about today or mentioning really is a team effort and couldn't do it without a great group. So since we're just starting the Tiger teams under the current generation, we don't have much to say quite yet about our work on the Tiger teams. But I thought this was a good time for me to instead focus on the core projects that my team had proposed, both under the last HAQAST that are now being published and under the current HAQAST. And so the 2 big projects that we had proposed under this project were to evaluate the AirMod regulatory dispersion model with tempo data, and also to be working with California counties and related stakeholders to evaluate offshore shipping emissions. And of these, I'll be talking today about our work with AirMod. And our shipping work has been moving slow and steady, and hope to present it at a future meeting. And if any of our California partners are online, I will be reaching out with updates shortly. But I also want to talk about some of the projects under our last HAQAST that are coming to fruition and about to be published. One project with the American Lung Association and Randall Martin's group looking at the applicability of gridded satellite-derived PM2.5 to health outreach metrics. Work that we did with the Rocky Mountain Institute. They were interested in whether satellite data could see building heating emissions on cold days. And finally, just kind of a shout out to Brad Pierce's work, which has been evaluating NOx emissions with satellite data, and that has resulted in a couple publications over the last years, including one that came out in January. So who here has worked with the AirMod dispersion model? Okay, a few hands. This is not a widely used model in the science community, but it is probably the most widely used model in the world. It is required by the EPA of every permit of large industrial facilities and power plants, but it's also used around the world for looking at how plumes disperse near the source. And over the last few years, my group has been getting more involved with AirMod, both to understand more what models are used in regulatory decision processes, but also to think about whether we can extend the application of AirMod to health and equity assessments. And that was done under complementary funding. So these slides are from my PhD student, Jinran Wu. She just defended her PhD about a week ago, and she is leading a paper that's coming out on this topic. So the way that AirMod works is basically a classic Gaussian plume model that takes hourly meteorology and uses it to calculate the plume within about 50 kilometers or less, often within 20 kilometers. One of the challenges, though, of evaluating this kind of localized model is that we don't have that much data because most of these plumes don't have nearby ground-based monitors. And now that satellite data are getting higher and higher resolution, we're interested in how satellite data can support improvements of AirMod and interpretation of the satellite in much the same way that gridded photochemical models have been engaging with satellite data for 10 years or much more. So one challenge in getting started with AirMod from a satellite perspective is that AirMod normally outputs just surface concentrations of primary pollutants, including NO2. But if we want to compare with satellite, we need the column because the satellites are seeing the air from space looking down as a column. So the first thing we did was develop use the AirMod capabilities. They call it a flagpole, as if you have a flagpole with a whole bunch of receptors. So we built a domain with a lot of flagpoles so that we could look at the vertical distribution. And then we started comparing how AirMod performance compares with tempo data. And this is at 2 different sites. And in some sites, the agreement, and this is looking just right above the stack, right above the plume. And sometimes the agreement is remarkably good. Other times it is not so good. These results are really hot off the press. And so we're trying to understand their characteristics and also what the performance looks like as you move away from the plume. We've also been using tempo data as a way of constraining the background to AirMod, because one of the problems with AirMod is because it's looking at a single plume, there's this question of like, what else is happening? And so what you're looking at here is on the left, the AirMod plume gridded to the same resolution as the satellite data with no background. On the far right, you're seeing the satellite column. And then in the middle, you're seeing what it looks like if you take the modeled plume and add it to the satellite-derived background. So again, this is new work, and actually, in addition to publishing a paper on it, we're working to develop a tutorial so that other people who are using AirMod, which is a lot of people, can also leverage tempo data to be supporting their work. I mentioned that we're also working with California counties. That is just starting, so I don't have too much to say here, except that it is a big challenge to think about how to capture offshore shipping emissions. And there's a lot of complex emission inventory development that is associated with that, which I've been learning a lot about. So in terms of what's been coming out of our last round with HAQAST, we've been working with many years with the American Lung Association. We were very pleased in 2024 when they came out with a series of reports called Something in the Air, where they were basically leaning into the idea that satellites can really play a role filling the gaps in monitoring data. In terms of what that can look like, on the left, you see US counties. And what I'm showing here are county design values. And these are based on ground level monitors, where the highest monitor in the county is used to calculate the design value. And we used the gridded satellite-derived data from WashU to calculate an analogous metric. We call it the county design value equivalent. It is not a regulatory metric in any way, but it is inspired by the same idea of taking some of the dirtiest, highest PM 2.5 grids and applying it to the county in a way that's very similar to how monitor data are already used. And so you see that we have a lot more coverage due to this. But one of the questions is like, well, it kind of looks the same if you squint your eyes, but what does it really look like if you zoom in on the counties where we have both the monitor-based design values and the satellite-based design value equivalents? So this is a paper that's led by my former student, Summer Aker, and we looked across those, and we started to call these true positives or false positives, but that suggests that there is a truth. And you know, what is truth? And I think that actually opens the question that we don't really know if the monitor data are better because maybe the monitors are missing a spot. But we also know that the satellite data has some issues. So we instead framed it as aligned positive. They both say it is above the threshold of the NACs that the American Lung Association uses, or aligned negative, or that one is positive and one is negative. And you can see across the US that most are aligned negative, that they both show that it's passing the PM 2.5 standard. Some show that it's both positive, but some are giving different answers. So what we did is looked at what are the characteristics that may determine whether they agree or disagree. And counties that have cities are more likely to agree. Counties that have mountains are more likely to disagree. These papers are in final stages of press and should be published in early June, and the American Lung Association is leading the press. So I'll happy to answer more questions. Our work with the Rocky Mountain Institute, they were interested in cold weather days and home heating. So actually my colleague Monica Harkey looked at that exact question, but it's very difficult to see whether NO2 is enhanced on cold days because it also has a longer atmospheric lifetime. So you have more of a buildup, but you don't know if that's because of the heating or because of the lifetime. So we've started working to build a better inventory of home building heating. This work is led by my student, Kara Scalpone. It's basically started veering further from NASA, but it was really inspired by this question from our HAQAST stakeholder. And that work should be submitted this year. And so that's it. Thank you very much.
A great talk. Save your questions again for Tracey. We have seats up here. If you want to come sit, great view of the lake out there. All right, so our next talk will be Angie Dickens from LADCO.
Okay. Hi, everyone. Good to be here. I'm Angie Dickens. I'm the data scientist at LADCO. And I want to point out that this is work I'm presenting. Well, not really presenting our work. I'm presenting a list of wishes we'd love for y'all to do. We'd be happy to work with you on. But Mark Jansen is our missions director. So everything he does is with emissions. So like he's full time working on emissions. So really it's kind of, I don't do emissions directly, but he does a lot of emissions. LADCO, we are the Lake Michigan Air Directors Consortium. We are what is called a multi-jurisdictional organization, or MJO. There are 6 of those around the country. And we basically serve as an intermediary between the states and the EPA. So we do, different MJOs do different things. We are the most technical, but we do the photochemical modeling for our states. So we're doing emissions for the modeling. We are running the models. We are, analysts, and I'm the data scientist. So I work with the data. We were founded out of a lawsuit around cross-state transport. So we work with basically Minnesota to Ohio, 6 states in the Great Lakes region. And we do kind of 3 different things. One thing is my boss likes to say we're the table around which the states gather. So they talk to each other mostly through our meetings. So we, help the states communicate with each other and work together. We do the technical work, the science. So we do the modeling, we do the data analysis that states use. Here we go. So that does include some work with satellite data, which we've mostly done in collaboration with researchers. And then we also help states with training, running training. You can see our footprint up there in the pink. So we use emissions inventories in a lot of different ways. One thing we do is we use it to understand what sources contribute to pollution and by how much. So that then helps inform state development of control programs and strategies, and can eventually result in regulations that actually, have real world impact and actually can lower emissions, which is great. I'll say that just hasn't happened as much recently, but it's built into the system. Other thing is to understand the impact of different emission control programs. So we use inventories and the models to understand if you institute, NOx wrapped on EGUs or on something, what will be the impact? Third thing is we use them as the inputs to the photochemical models. Mentioned we do the regulatory modeling for our states. So the modeling that they use to meet their Clean Air Act requirements. We do a lot of work validating emissions, and not so much me, but others on the team do work full time on that. Still, there's a lot of uncertainty, of course, and there's a lot of remaining needs for verification. So I'm going to put out 2 areas where we could really use help from satellites. First is really validating the inventories. So this is one of the ways we look at our inventories, it's kind of pie charts. This is NOx emissions for 2022 in our 6 states. This is from a recent as in like last month, report on the inventories in our states. And, pie chart showing the relative share of different emissions from different sectors towards total emissions in the region. We have these by state, we have these by non-contaminated areas, we have them by county, and so on. But one fundamental question that satellites have a potential to help with is what are the relative distribution of different emission sources, and can we distinguish between them, between things like on-road and non-road mobile sources here? We have pretty similar magnitude, really, really important. Can we tell from the satellite which is more important? EGUs, electric generating units, power plants, and industrial point sources. Also, it would be really nice to be able to distinguish better between emissions from sources and energetic versus natural sources. We really want to know where are our inventories right and where are they off and in what ways are they off. And this is another way we look at inventories on a map basis and looking mapped out by sector. Also from the same report. So I think the spatial and temporal resolution of tempo has the potential to really help this a lot. The spatial resolution we can combine with really high resolution land use data. Also, compare with maps like this where we know or think we know where the emission sources are. So, compare and see whether the spatial distribution is what we think it should be and where is it off. One question is there fine enough resolution in the satellite data to really do this? There's some, challenges with that. Temporal patterns, with tempo, we have the temporal data, and we know different emission sources have different temporal profiles. So can we use that to kind of hone in on sources in a different way? We have these natural experiments, time of day, weekday, weekend, holidays, and that. So that's another way we could potentially use that temporal data to get at emission sources. And then combining the spatial and temporal patterns can really also help kind of take things to another level. Some suggestions for how to make your science useful for an emissions developer. The main thing is really provide enough information to inform a specific aspect of the inventory. Be basically as much specificity as possible. I can't tell you the number of times I've heard Mark, our emissions guy, talk about, the scientists say the emissions inventory is the NOx is two times too high. It's like, that's not useful. He can't do anything with that. You're not going to just, in practical, in a SIP submission, you're not going to just say, oh, we're just going to dial, or NOx down by a factor or two. Whereas what is useful is things like really sector specific information, like on-road gasoline VOC is 30% too low. That's useful. Temporalization, NOx in Chicago is 20% higher in August than in May. That's useful. Chemical speciation. If you can talk about the species that are comprising VOC, midday VOC in rural sites in Michigan. It's a lot of specificity there. It's useful. It's sort of something we can take into our inventories and use to adjust and verify and justify. Also spatial allocation, VOC emissions in Nashville 3 times higher than rural Tennessee. That kind of thing is useful. Last point then is just talk with an inventory developer. Mark was happy to talk with researchers about that. I know Brad's worked pretty closely with him. I think people in Tracey's group have. So it's another way to just make sure, because there's a disconnect, and that's one of the roles LADCO plays as well, as connecting researchers and regulators. So talk with us as well. Other thing I want to point out or ask for is more selective oversampling. We have these beautiful maps, oversampled maps where you're combining lots and lots of data to get these nice spatially continuous maps of NO2 in particular. They're often averaging a year, several years of data, which is great, but you have lots of different weather patterns, lots of different wind strengths, wind directions, temperature. Some days have high ozone, some days don't have high ozone. You're averaging a lot of things together, which makes it harder to connect to inventories. So you get these large blobs that are cool, but not as great for evaluating inventories. So one thing you could do is oversample based on common meteorological patterns. It's a paper by Dan Goldberg from a few years ago, not 2004, as I think I said last night talking to him, 2024. Where he was looking at, this is the, average of all of the days. He also averaged days with tropomi, so once a day, but with slow wind speeds, less than 3.2 meter per second, fast wind speeds, and then slow summer only. And the idea is, with slow wind speeds, you're not kind of smearing the signal as much. You're getting emissions that are going to stay closer to the emission sources, which is going to make it easier to evaluate emissions. Another way you could look at it is wind direction. Pick up look at, when you have winds from the southwest. And you're going to have a common distribution pattern. So it's another way to look at it. I know people have been doing this looking at city plumes, but could do more oversampling there. Synoptic weather types. One thing we would really be interested in is high versus low ozone days. Also if you're looking at PM, high versus low, like winter nitrate, for example. Another idea, which Dan told me last night isn't crazy, would be to develop a tool to allow the user to select which days and times to combine for oversampling. That would be really cool. I would love to be able to go in and say, okay, these are my high ozone days, and high ozone days with low wind speeds. So I'm going to look at those. And obviously you need enough days to really get a meaningful oversampling signal, but that would be really, really useful. And I think with that, I'm going to stop and hand it off to Jen.
Thank you. All right, great talk. Our next talk is from Jennifer Kaiser from Georgia Tech, who's also a HAQAST member.
All right, thank you. It's so nice to follow Angie because much of our work has been motivated by LADCO wish lists. And it'll also allow me to skip through our introduction bit and maybe go a little faster and save some time. So specifically, the project I'm going to be talking about is evaluating ozone sensitivity using CMAQ and giving you an update since the last time we discussed this. I'll be focusing on evaluating our CMAQ models with Tempo version 4 and NO2. And before I go further, I want to thank the graduate student, Ariana Moore, who's put a lot of work into this, and then familiar faces that you might know, Young Talat and Ted, my colleagues who have really started this work off. Here's the introduction that I get to skip. So the important question is, ozone hasn't gone down much. The low-hanging fruit has been picked. What's left? Can we find specific, maybe not sectors, but what time of day might turning a sector down have the largest impact on an MDAA ozone? To answer that question, we use the CMAQ direct decoupled method. What we do is we evaluate either NOx or VOC sensitivities. You can see our anthropogenic NOx sectors and our anthropogenic VOC sectors there we focus on. And then we say, if we tuned those down at a certain time of day, what would the impact be on modeled ozone? And this is an example of some of those results from a prior study. You'll see the dates here in 2016. On the left, I'm showing sensitivities to NOx in the Chicago region and Milwaukee to VOCs on the right. So you can see that time of day might be a parameter that is important for thinking about regulatory strategies some of the times. So for NOx in the Chicago region, we see similar impact across all daylight hours, but maybe different sectors have different importance at different times. If we trust our model, then consistently we see that there's high VOC impacts in the early morning as well. So a big question I have though is this actually right at all? This is all modeling space. Are we based in reality? So taking that prior project and moving it forward, what our goals were to update this to more current years. That was in 2016, and that was actually 10 years ago. And then also to evaluate this using Tempo version 4, NO2, and expand our area of focus beyond the Chicago region or the Great Lakes region to the Southern California region as well. So diving into what we see, we're using Tempo version 4 to say whether or not we can trust our CMAQ model results. But first, a question I have is, can we trust Tempo version 4? In the last HAQAST meeting, I stood up and told no one to use tempo observations before 10 a.m., but I am a convert now, and I'm very happy with what I'm seeing in Tempo version 4. I'm not showing you a comparison with Chicago region, but rather our network in Atlanta. We've got sites that span the urban core to the rural region, and I've compared tempo versus these kind of gold standard measurements, Pandora, on the x-axis. And what you'll see is we no longer have a bias depending on what time of day there is. These are colored by time of day. They're all along the 1-to-1 line. There's no bias depending on whether you're in the urban core or out in the rural regions. Those normalizing bias were like 1%, 0%. I'm very excited. So I think this is a strong starting point for model evaluation. I trust Tempo version 4 to evaluate our CMAQ observations. I will say this is kind of preliminary since Tempo version 4 isn't all the way back processed yet, and I've only really looked at Atlanta, but city-specific validation is important as well. All right, so if we trust Tempo version 4, can we trust CMAQ? What I'm showing now is CMAQ. This is 2023, averaged each hour for the month of August, and we're cycling through time of day. CMAQ on the left and Tempo on the right, and then the difference on the far right. So some bullet points to see. The spatial variability, I think, is fairly well captured, meaning where there's hotspots in CMAQ, there's also hotspots in Tempo. We see midday when we cycle through here to maybe 11 a.m. or 12, those colors are near white, meaning there's not a big difference between our model and our observations. But in the early morning and in the later afternoon, we're seeing a lot of red, meaning bias is potentially in CMAQ. In case that video is hard to follow, I've put it here in early, middle, and end of the day as well. We see those bright red versions or bias maps in the morning and the afternoon, and closer to white in the middle. Some advanced users might know that these maps really depend on the underlying assumptions in your Tempo retrievals. This is the standard product you might download, but alternatively, you can update the a priori vertical profile. So if we assume that CMAQ has the right vertical profile and use that in our observations, how does that change our comparison? I say we still see near zero bias midday. That's phenomenal. And potentially same biases in the early morning and in the late afternoon, maybe some different spatial patterns in those biases. To dig into this a little more and the implications of this, I'm going to focus on the urban regions where we have our NOx emissions, and we're really trying to use our Tempo to constrain our NOx emissions. So I'm showing these now as diurnal cycles, our NO2 VCDs on the y-axis, time of day on the x for St. Louis and Chicago. So in our urban regions, the default Tempo and Tempo with the updated air mass factor actually align pretty well. So it doesn't make a large difference in the regions where we're trying to constrain NOx emissions. Does CMAQ get that diurnal profile right? It seems to depend where you are. Maybe you see more of a smile in CMAQ and more of a flat line in Tempo in St. Louis. In Chicago, maybe the shape is different, but those numbers are very close. So I think you'll see different stories in different regions. And this may suggest that there are different needs to refine emissions in different regions as well. Moving on now to our newer domain. This is very hot off the press from Southern California. Those prior CMAQ results were at 12-kilometer resolution. One of the benefits of CMAQ is it's high resolution. So we're running CMAQ, or one of the benefits of Tempo is high resolution. So we're running CMAQ high resolution 4 here as well. Before I show the video, I'll tell you what to look for. We're not seeing the same pattern of biases that we saw in the Chicago region. We have different biases, suggesting that there's some location-dependent differences. And then what we'll also see is that this higher resolution, our differences might not reflect errors in emissions, but errors in transport. And now I'll show you that video. So this is the South Coast region. We see that NO2 plume move inland throughout the day in both CMAQ and in Tempo. And then what we see on the far right is bias maps that have dark blue right next to bright red. And to me, this signifies that maybe there's not a bias in the total amount of NO2, but where the model is putting that NO2. So there's more to think about than maybe just a simple point-to-point analysis may be able to tell you. Highlighting again regions of high emissions that are of interest to us, we find that the ports matter a lot in our ozone modeling. So if we dig in specifically to our biases in the port region, and then we'll also look downwind in San Bernardino. We see Tempo and CMAQ have similar temporal patterns near the ports. So this to me says perhaps we can use Tempo to constrain your port emissions. San Bernardino, the temporal profile is quite different, potentially again reflecting those areas of transport as we move inland. So I'll leave you with some takeaways and some next steps. Again, overall, our ideal goal is to use a model, CMAQ DDM, to help decision makers understand the potential effectiveness and impacts of emissions controls because the low-hanging fruit has been picked. We don't know if our models are right necessarily. We can evaluate against ground-based observations, and Tempo gives us another more spatially complete and temporally complete way to evaluate our models. And when and where Tempo and CMAC agree, that's phenomenal. It builds confidence in our model results. And I do want to I mentioned the Tiger team earlier this morning, but looking forward, this has been very NOx centered. VOCs are important for ozone as well. So that's why we're moving forward using Tempo formaldehyde to understand VOC emissions in these regions as well. Thank you.
So our final talk for this session is from Sarah Benish from the National Atmospheric Deposition Program.
Thanks, everyone.
Well, yeah,
Okay. There we are. All right. Hi, everyone. I'm Sarah. I'm National Atmospheric Deposition Program. I actually started as an NADP coordinator about 6 months ago, so I'm very excited to be here. I actually attended an HAQAST meeting a long time ago. I'm so really excited to be back in the HAQAST world. If folks are familiar with NADP, you might remember David Gay. He retired a couple months ago. So today I'll be talking just a little bit about NADP, what we are, who we are, kind of bring it back to the ground for a minute, and talk about 2 special projects that we are working on that kind of go outside the normal scope of our operations, and then end with some ideas for our communities to kind of work together more in the future. So NADP was originally established in 1978 to understand the impacts of acid deposition on ecosystems. If you're interested a little bit more in the history, I'm talking more about that tomorrow during the outrider portion. So I'm really focused on the future today. But we've been measuring acid deposition across about 300 sites, 350 sites, depending on how you count our different networks, for almost 50 years. And we have all of our data free and available on our website that can be downloaded at any time. So we operate a variety of different networks. Our first network is the National Trends Network, or NTN. This is a weekly wet deposition and concentration of a variety of different things, nutrients and rain, acids, cations, things like that. This is a picture of our sampler out in the field. And we're also really excited that we recently launched a PFAS subnetwork of part of NTN. This actually launched last month, and we're expecting our first data products on the web sometime in July. So we have about 15 sites across the United States that will be reporting weekly samples of wet deposition for 40 different compounds, and we're expecting to launch some method development to do the shorter chain compounds over the summer, measuring things like TFA. So really excited. Stay tuned, hopefully for a future presentation to talk more about PFAS. But we also have a variety of different mercury networks. We have mercury in rainwater and deposition. We have mercury in hourly gaseous elemental concentrations called AMNET. And we also have mercury in leaf litter for total mercury at about 25 different locations across the US. We're also really excited that we launched we're in our second year of our passive mercury pilot program, where we're measuring quarterly average gaseous elemental mercury concentrations with a passive sampler at about 15 locations in the US. It's kind of complementing all of our mercury work. And last but not least, we have our ammonia monitoring network, or AMON, that's gaseous mercury, talking about mercury, ammonia concentrations in 2-week samples. This product in particular has been utilized a lot by the remote sensing community for satellite retrieval validation. Last but not least, since we measure rain, we also have our electronic rain gauge for all of our NADP site network at 15-minute hourly and daily resolutions. That's posted to the web about 1 to 2 weeks afterwards. Just quickly about our governance, since we are operated by the State Lab of Hygiene, but we are actually led by an executive committee that makes up federal scientists, university scientists, public sector, private sector, all of that. Our executive committee oversees our technical advisory and science committees, making sure that the data that we produce is consistent over the 50 years that we've been in operation, that our education and outreach are, communicating the science, and that also we have a budget committee that makes sure that we are actually keeping on budget. So that's exciting for me. In addition, we have a couple different science committees that are led by a lot of federal and university scientists, and I think there could be some really key overlap here. Things looking at the critical loads of deposition to certain types of ecosystems and certain types of environments. There's a total deposition that uses a measurement model fusion approach to look at total deposition that I know there's been some interest to include satellite data in that product. We also have some aero allergen work as well as some mercury impacts on the environment. So we're operated by the state lab, but really we're a kind of affiliate of a state ag experiment station, US DA NIFA project that has a variety of cooperators in the federal sector, US states, tribal organizations, universities, and other international organizations like Environment and Climate Change Canada and EPA Taiwan. So there's, I guess I'm at some level the face of NADP, but there's a lot of scientists that go on to use the data, to collect the data, that sponsor the data, that are all very much involved with NADP. And we produce about 150 to 250 research publications every year using this data. Really spans quite a large area of different types of science, satellite retrieval validation being one of them. So with the remaining of my 5 minutes, I'm going to talk about two special projects that kind of go outside of the scope of our normal NADP operations, our bread and butter, and kind of look to the next generation of deposition and science, and maybe some opportunities for some satellite data involvement. So the first project is looking at black carbon in precipitation. This was work that was led by a student at UW, as well as the former director of the state lab, Jamie Schauer, and my predecessor, David Gay. They looked at rain samples from November to December 2020 and measured for refractory black carbon, masked black carbon. The map on the top is showing the hazard mapping system smoke map for the study period, with the blue dots showing all of the NADP NTN sites. The bottom map is the black carbon deposition that was produced from this study, showing that there are how smoke plumes were able to impact the black carbon deposition, but also there were some areas that there wasn't an obvious smoke source as well. This is just kind of a one-time study, but there are a lot of different ways our rain samples can be used to measure new and exciting things that are going on in the atmosphere. The second project I'm going to talk briefly about is our total nitrogen and total phosphorus and precipitation project. This is a sampler that would accompany our normal NTN collection bucket. You can kind of see it at the top right photo with the black thing kind of like snapped to the bucket. So this would analyze for the total nitrogen and total phosphorus component, which historically NADP does not measure the organic portions. So this would be really exciting work to get to that total nitrogen and phosphorus budgets that have impacts for things like algal blooms, as you can see from space from 2024 over Lake Erie. We've done some preliminary testing with this sampler to find that it is collecting and it works side by side in comparison, but this is work that NADP cooperators at the National Park Service and Colorado State are continuing to work on. So really excited to see how that develops in the future. So lastly, just kind of concluding with some ideas about how our scientific communities can work more together in the future. I've talked a lot about what NADP offers in terms of data, but I'll just add maybe that we keep every rain sample that we've ever collected for 5 years for every site. So we have a lot of rain that I would like to try to get rid of if people want to do some exciting science. And then for a subset of 10 sites, we actually keep every rain sample that we've ever collected frozen. So there's some really cool kind of long-term change studies that could be done. Our fridges are not too far from here, about a 10-minute walk that way. So. But there's also really a lot of opportunities for NADP to get more involved with the remote sensing and satellite data community. I put up some ideas, and Angie also mentioned the temporal resolution, and Jen as well. You know, our samples are primarily 1 week or maybe 2 weeks, and so having that temporal understanding would be really helpful. Another part would be understanding that dry deposition component better as well. Historically, the EPA's Clean Air Status and Trends Network, or CASNet, has been doing the dry deposition part, but I think there's some really key ways that satellite data could be used in informing the dry deposition. So I'd love to talk to folks more about these types of opportunities. And if you need extra motivation, I do have some NADP swag that you can come and get. I have some calendars and I have some rain droplets that are like the stress ball things. So if that doesn't get you excited or not. And just a quick plug, we also have our spring meeting next month in Madison. If you really want to talk more about acid deposition, it's also hybrid as well. So I will end with less than a minute remaining, and here's some of my contact information as well as the key image on our calendar from last year. Thanks.
All right, so now we're open for Q&A. We'll kind of take preference in the room first here, obviously, and open for questions for any of the presenters. Brent.
And the work that we're doing, then the work you're doing in California is a CMAC at 4 kilometers. One of the things first of all, it's great to see that before the tempo is looking so robust. What we found when we compare our model during the Corona Stacks campaign is that impact of the apiary is most clear like over water. And I saw in your figures that temples seem to have a lot over, over the Pacific. And have you looked at whether or not you see a difference if you use the CMAC apiary for that case? That's going to be particularly important for your shipping mission.
Yes. Thank you. It's a phenomenal question, and my student has done that comparison, and I have not looked at them. So I will follow up with her and let you know.
Yeah, with that GeoCF, quarter degree resolution kind of leaks a lot of stuff out.
That makes sense. Thank you.
All right. Question?
My question is for Tracey. Thank you for the presentation. I am with the Chicago Climate Institute, and we might be works with the EPA to develop predictive analytic models to predict the risk of violation for facilities under the clean air, clean water. So we have a clean air model that we're developing right now, and we have satellite data as features. And of course, the challenge there has been attributing these concentrations to facilities. So in your first slide, it was really exciting to see that the air more tempo bit is in progress. We're a small team, we don't have as much bandwidth to do all of this modeling on our end. So what does the end product look like at this point? How can we integrate it, and what's like a path forward? Correct.
So thank you for the question. And I think that the end, I don't think there will ever be an end or just an evolution, but it really is just beginning. And I want to say that back in 2015, maybe 2014, those were the first papers that evaluated CMAC with satellite data, because for maybe 10 years before that, there had been analysis of global models at coarse resolution with satellite data. But the idea of satellites supporting 36 kilometer or 12 kilometer, that was quite new. And once we were able to connect satellites with CMAC data, then we could start evaluating emission inventories. And it is true that a lot of those assessments are saying like the satellite is higher and the city is lower. So there's some problem, but at least you're able to begin to start those kind of questions. And I think and then move forward from there. So I think now things are quite far along with CMAC and CAMX model evaluation with satellite data, but it's only because of the TEMPO instrument that was launched in 2023 that we can even think about evaluating individual plumes with a plume-based model. So I really see, AirMod as the next frontier of this kind of model evaluation. But one of the funny things about it is that, atmospheric scientists like to study the atmosphere and how it swirls and turns and is realistic. But AirMod does not do that. AirMod just assumes that you have kind of a cone coming out from the top of a power plant. And so you actually have very few atmospheric scientists who are using in a serious way air mod, which then actually is sort of a gulf. You have the satellite data that requires a fair amount of expertise. And actually air mod is not easy to use, but it tends to be more run by consulting companies and engineers. And I think that there's a lot of potential to be bringing them together. And actually, but as you move forward, you need these kind of modeling tools to do attribution. I mean, I think that's the question, attribution. And attribution was at the heart of a lot of Angie's wish list items, like how can we attribute satellite data to individual emission sectors, and with Jen's comment. And, I think some of Sarah's work kind of could tie into attribution. If you're really thinking about the co-emissions of mercury, that's an indicator of coal, ammonia, an indicator of ammonia. So, I guess, where does it end, or how does it all tie together? I guess I would just say, hopefully conversations like this might give even, serious modelers might take the time to learn air mod, but also hopefully more environmental consulting companies and engineers who may not have thought that satellite data could be useful might see a point of connection. So great to have you here.
Great question. All right, next question from somebody in the room here, hopefully.
Oh.
Thank you. I have a question for Angie and Dickens. My name is Lolo. I work with Naeger right now. So very nice to see your presentations. So I'm interested in the part of using Tempo to distinguish emissions from different sectors. I was wondering, especially the on-road sector. I would actually, even for this sector, different types of vehicles have different types of dyno variations, especially like passenger cars and trucks. So they contribute, so different to the NOx emission especially. So I was wondering, do you have any thoughts or like plans in future to like distinguish and to special emissions from these two types of vehicles? Thank you.
Yeah, no, I think it's exactly what I think there's a potential to do. And I can say, we with Laura Judd flew staff or the GCAST during LMOS 2017, and then also again during Asia plus Chicago. That sort of something. And it was something that Mark noticed in the pattern in LMOS. Is like you see, like there are highways in Chicago that have really a lot of heavy duty diesel traffic, and highways that are mostly light duty diesel traffic. And he was basically in the GCAST, which is basically the higher resolution, what we see in Tempo, is seeing like the heavy duty diesel highways are very clear and the light duty ones just don't show up. And so I think that's sort of something we've been talking about trying to dig into. And I think now having more data from Tempo that definitely opens up. And that's just spatial. That's just sort of looking at where you have the heavy duty versus light duty. But I think, the temporal, because like the heavy duty is going all night. Well, we don't have tempo at night, but like they're more of a steady, profile, whereas the light duty, you have a real clear, the rush hours. So I think there's definitely potential there. It's something that we would probably do in collaboration with someone else or ask other people to do that, but we'd be happy to collaborate on that. So I think that's the idea that Tempo is such rich data that you can start doing that kind of thing, which we couldn't really do. Or we could do with like these special, 3 flights a day or, 5 flights. But like there's a lot more potential now. We have every day, for, multiple hours. So I think there's a lot of signal there that we have yet to untangle.
Thank you so much.
Yeah.
Do you have the traffic data in that area to really look at the diesel or different trucks versus passengers and all that?
I think so.
You do? Okay.
Yeah.
California, that's pretty good.
Yeah. I know we, Mark has worked at CMAP, is the Chicago Metropolitan Area Planning. They do a lot of the traffic work. And so I think we've bought some data sets. They bought some data. Brandon maybe know too, but there's, I know some of it's public and some of it's not public. I know we had one project where we were working with I'm forgetting like transmitter data, but so some of it's public, some of it's not public, some of it's expensive, but there is data.
Yeah, I was just gonna add to your comments, so thanks for noting the airborne work, and I remember those comments from Mark. And thinking about it, like I really loved your slide where you talked about expanding oversampling to different time periods, different seasons, different times of day. And I think tempo is really enabling the data volume. So to think about that. And so if we know a little bit more about the activities of the vehicles from a different source, like you were just talking about, and we think about how can we sample tempo to distinguish those two. And I don't have to answer, but I think it's a great idea. And I'm hoping the thinking about how to piece together tempo data in different ways can help us reveal these questions. Yeah.
And so what we have in hand is we have our inventory temporal profile. You know, we have our inventory temporal profiles, and we take those down to we do our modeling on a 4 kilometer basis now. We have that at 1.3 kilometer basis. So we have that just in hand. That's sort of what our inventories think is happening. You know, Mark does collaborate a lot with CMAP and a few other metropolitan planning organizations, most in Chicago, where they do have more granular data. So it was popular to go deep.
Kind of wanted to follow up on this. So getting back to Angie's request for, sector specific things, I think that the work that Jen's doing and Dan's doing with the decoupled direct method, that addresses that. And we can see that 250 meter resolution aircraft measurements can detect differences between different sectors. But we need to understand that to model, if we're going to be modeling something that like changes in roadway vehicle traffic, that even the 4 kilometer is not going to be adequate to do that. And in the same way that we've gone from looking at global models with polar orbiting data, we're now drilling down, and it's going to be a challenge for the modeling community too. We can run models at high resolution, but the highest resolution emissions that I know are still like 1 kilometer emissions. So that's just something I think is a challenge to the modeling community.
Yeah, and I can say from an operational modeling perspective, you know this, Brad, that we run models for the states. We did a 1.3 kilometer run a few years ago and found it actually didn't help that much more versus a 4 kilometer, and it's so intensive, the computing so intensive. So we went back to doing 4 kilometer from a just practical perspective. And so it's sort of something where, yeah, you're right. You need the higher resolution, but like running it for Clean Air Act purposes is going to be challenging.
And kind of on your sector analysis you did, I noticed the agriculture sector, it was very, very small. I kind of thought maybe a little larger in that region of interest, but maybe that is what it is, as you can comment on that.
I mean, that's our best estimate, right? On the inventory, and it's across all 6 states. I think there are going to be hotspots, but I know there's the Farm Flux campaign, and I'm not sure if the someone from June Wayne's lab who's here working in Farm Flux and like looking at the soil maps. So I think it's something we know we're probably not getting right, and so maybe the Farm Flux campaign will help us get that better. So I think that's in one of the categories where like, we have numbers, but they need some.
Yeah, great. Anyone else in the room?
We have one online.
Okay, sure. Let's take it.
Thanks. This is from Doug Boyer. I really like the complimentary talks by Angie and Jen. Jen's presentation really showed the importance of the temporal profiles of emissions in photochemical modeling. Is Tempo V4 improved in the morning/evenings versus previous versions that we can trust the profiles for model/emission evaluation during those important hours?
I think I could talk about this, but there are people with more expertise in the room that I will defer to.
No, I mean, I think you showed a great example. I mean, I've been looking at the version 3 versus version 4 data too, and it's much improved. I mean, you can look at the morning data now. There's been major algorithm improvements. This sounds awful, by the way. Yeah, so I mean, I have much more confidence in the use of tempo data for these kind of activities, what I've seen to date, and kind of Jennifer also highlighted that in her talk. So to answer that question fully, good.
I'll agree with what Aaron and Jen said. This is Lori Jen. So nice to see you online. I think she showed a really great example in Atlanta where, yeah, it looks like it's great no matter the time of day right now. What I've seen with the cities that we measured during stacks, it also looks great. But I do think specific cities should still look at their specific validation sources just to make sure that there isn't something weird going on. If each city is unique in terms of the distribution of emission, the meteorology, the surface reflectivity, and but I think it's moving in a really good direction for version 4, and it looks really good so far.
I'll point out a small nuance in the comparisons I showed. It's actually the worst comparison was not urban or rural, but the one in between. And this is where we sometimes have plumes from the airport hitting us. And the ability or the comparisons between Pandora and Tempo become just, I think, more complicated when you have a plume hitting you and thinking about what a discrepancy there means and is it meaningful. That requires nuance. And if there's a lot of point sources that are needed, you could see potentially even more careful consideration needed about how to interpret those comparisons.
What else in the room for a question?
Thank you. Eric Rokowskis, Peter, do you want to have a question for Tracey? Just mostly curious, when you were evaluating the tempo versus the error mod, you mentioned a couple of times where you showed a couple of graphs, I think some slides where for the most part they were in alignment, for a couple of spots where they weren't. Was there anything common about that, the time of day or weather patterns or anything like that you evaluated?
We are really, this is hot off the press work, so we haven't gotten that far. And I think, one challenge about about air mod is that because air mod is facility by facility, you might have 10 facilities who have very different behavior. And are they coastal or inland? Are there complicating meteorological factors? So, and when we're presenting this, we talk about it as facility A or facility B, because we're not trying to shine a spotlight on a particular industrial facility and bring regulatory scrutiny onto a facility. We're really just trying to find facilities that seem well suited for comparison with the satellite data. So I would just say, that work is kind of just maybe getting out of the gate is underselling it, but I think that we've been excited to see that we can do some rigorous comparisons, both over time and over space. We have a few sites that we're looking at. And, I think, we're focusing on power plants in part because power plants report their hourly emissions. So it's better suited for evaluating the model. I think if you were to take this a few steps further, and it would be interesting because there's a lot of non-power plant large facilities that do not report their hourly emissions. They only report annual totals. And so I think that there's a potential for Tempo to be helping to sort of back out what some of those emissions might be. So, I'd say I don't really have much more than what we have shared, but, this is a growth area and it's, I think that there's a lot of potential here. I think there's potential in using satellite data and satellite derived data products to support background concentrations of air mod for regulatory modeling. I think there's the potential, to evaluate air mod performance and improve the model. I think this is really a big issue because, if you don't have data to know how the model is performing, then you don't have a good direction for improvement. And this is a model that, any improvement would have a huge, huge impact on policy, regulatory, and health applications. But I would also take it the other way that if you're trying to understand even what's happening with a plume from tempo, and you want a model to help you kind of be a lens to understand the processes, AirMod could be an interpretive tool as well. So I think that there's, a lot of potential here, and I hope that everyone in this room starts using AirMod. And if you want to learn how, we actually have a tutorial on our website that was led by Daniel here, who's now doing our AV. But before he handled the AV, he wrote an AirMod tutorial, and that's on our website right now. So, I think our hope is to this is already a widely used model, but it's not as widely used in the science and satellite community, but I think it could be.
Hi, Maurice Roots from Madison. I have a general question directly, I think applicable to Angie. How important is the non-terminal space for your work? I know this is a satellite thing, so that's popular, but how does that factor in? Will be factored in?
Yeah, I mean, nocturnal missions are definitely important. Yeah, they happen, and they're an area that satellites are. Well, I mentioned earlier that the heavy duty, a lot of the long haul trucks go all night, and we're not going to see that with satellites. So I think it's definitely we count them in our inventories, and it's harder to verify, at least with this kind of with satellites or with any kind of field campaigns also aren't flying overnight generally. So we know the emissions are happening. We also know you get different kinds of chemistry, different kinds of just things are different at night, and it affects what happens. Daytime for ozone, but obviously it's for PM2.5 is we think it's more of a 24-hour average. So yeah, it's definitely important, and it's hard to verify. So Brad,
just have to make a comment. Don't generalize satellites to the UV vis satellites that we're used to using in the air quality community. There's a lot of extremely valuable hyperspectral infrared sounding instruments that, for example, do ammonia retrievals, and they do them day and night. So there's the dark side that we can't look at. We can't look at NO2. We can't look at PM2. Can't look at aerosol optical depth, except for things like dust optical depth, which you can do at night. So think about infrared. That might be an area that HAQAST should be considering more broadly, particularly with farm flux coming in.
There's a question.
Does Chris get over? Does it measure overnight?
Yes.
Okay. Yeah, and I know the last HAQAST I was putting out, I'd love to use Chris for VSE.
Things are different at night. How?
Well, I mean, the NO2 goes into reservoir species. You have just different emission sources. Some things continue, some things stop. You don't have photochemistry. You don't have the light, but you have other things are happening. So
shallow.
Yeah, shallow. Yeah, but the meteorology is different to the planetary boundary layer. It's really hot, lower, so you get buildup of. You build up of a lot of things that are around, in a narrow layer. Emissions will stick close to the surface. So yeah, it's a really different kind of thing. You don't have ozone, but the ozone can go back to form energy when you just form 10 there's just a lot of different things. So yeah.
Anyone else in the room? Do we have anything online right now or no? No. We have a few more minutes left. Or a couple more questions. I got one.
I think it's off. Try to be loud. I have a question to Jennifer. I'm using technical data as well. So currently I'm using the temp data from 9 a.m. to 4 p.m. So I'm very happy to see the good abundance before 10 a.m. So I was wondering, maybe I missed it. So I was wondering how about the late afternoon hours? Have you taken a look about the abundance at late afternoon hours?
So yeah, in Atlanta, we're seeing you can choose any hour that tempo's observing, and it will agree just as well with Pandora as any other hour.
In even our version 3 data compared better in the evening hours compared to the morning. So early morning.
Thank you so much.
What else for a question? Lingering question that is critical.